I'm Laurent Masia from NETGEAR, and let me take you through this question: why is IGMP so important for perfect AAV over IP? So before we start, let me tell you a few words about NETGEAR. NETGEAR is a proud co-founding member of the SDVoE Alliance. Now NETGEAR is a steering member of the SDVoE Alliance. So of course NETGEAR supports all the SDVoE manufacturers, but what you need to know is that by far the NETGEAR AV line is the most recommended AV over IP switch platform. You can see here over 180 manufacturers that went through very strict mutual certification process with us, so that you make sure that not only SDVoE but also all other AV components from audio to video will work seamlessly. So let's go to this topic today. What I'm showing to you right now is the most simplistic installation for a SDVoE topology. You have one switch in the middle, that's your fabric, right? On the left-hand side, you have your endpoints for sources, so the encoders that will packetize HDMI video into packets. Goes through the fabric. On the other side, you have all your receivers, other SDVoE endpoints that will then be rebuilding the video files together and displaying them on your displays. So you need to be aware that even in such a simple installation, IGMP is at work, the courier is at work, and I need to explain it to you because sometimes things are not that simple. As soon as you have multiple switches in the network, you've got to know IGMP very well. So what is AV over IP? Well, AV over IP switching, as far as the switch is concerned, it's only multicasting. And why is that? It's because you have three main types of messages on an Ethernet network. You have unicast, point-to-point communications, just can't work for AV over IP because one sender should not send multiple times content, right? And the second form, very well known, is the broadcast. That would be criminal for AV over IP. You don't want to broadcast your content to all ports at the same time. So multicast is a beauty because that's a one-to-many form of transport. All AV over IP implementations, including the SDVoE transport and codec, leverage multicast. So with multicast, you just got to know that on top of the unicast IP and MAC addresses, you have some more logical MAC address and IP addresses, 224 to 239. So take it this way, every AV over IP installation will do multicast on your network. So let me take you through this IGMP question. How does it work exactly? So take this installation. That's a single switch, very easy, right? And in that single switch installation, you have four encoders on the left. Each encoder is attached to a audio-video source. And you have four receivers on the right-hand side. With your SDVoE installation, you have not only the endpoints, encoders and decoders, but you also have your controller. So as soon as you will connect those encoders and decoders to your network, the controller will discover those endpoints and classify them between source and destinations. So the controller is controlling your video endpoints, encoders and decoders. All right? So let's put it to work. What you need in this very simple first installation is a mouse in order to control the controller. And let's say that you want to attach or pair the transmitter encoder number 1 with the receiver upper left number 1. So you will drag and drop in your SDVoE controller this T1 and pair it with R1. What happens at that time? Well, this SDVoE controller will send instructions to your endpoints so that the endpoints can put IGMP to work, because the switch, which is again the fabric, this switch doesn't listen to the controller. This switch will just work per the IGMP protocol with encoders and decoders on the network. So follow my logic, you just did that, right? So you drag and drop T1 to R1, the controller just sent the instructions to your video endpoints. What happens? Well, the decoder R1 is sending an IGMP report, right? Saying that this decoder wants to get to the 239.1110. So this IGMP report goes where? Goes to the courier. Here, it's a simple network with one switch, so the courier resides on that switch, and the courier gets that general reports. So the courier in returns sends a IGMP query. Do you want this 239.1110? The query goes back to the Air R1 decoder, and this decoder answers, yes, I want that stream. As a matter of fact, the IGMP snooping on that switch in the middle can snoop on those queries back and forth, and now you have this association on the port 16 of the switch between the video source, which is 239.1110, and the receiver number 1 that has subscribed to it. So technically speaking, you formed an IGMP group, and now the switch can let those packets go freely between the port where the encoder is and the destination port. All right? So again, it's really important to understand that the courier is absolutely mandatory. Okay? Without an IGMP courier, EV over IP couldn't work, because those video SDVoE endpoints couldn't let the switch know what to do. All right, so let's accelerate now. Let's say you want to, this time, pair the transmitter number 2 with the receiver number 2. What happens during that? Well, the controller is sending the instructions to the receiver number 2. The receiver number 2 sends an unsolicited IGMP report saying, I want to listen to 239.1120. The courier will answer back with a query that will be acknowledged by this receiver number 2. The snooping table is updated, and now you have the packets flowing from the port where the transmitter number 2 is up to the destination port, which is the port 15. So now you can actually do that several times, pairing up the T3, transmitter number 3, with the receiver number 3. Again, the IGMP protocol is put at work on the switches. If your switch is correctly configured for the snooping and the courier, this will work seamlessly as per the IGMP standard. All right, so we are doing that a last time with the transmitter 4 and the receiver 4. Now you have a one-to-one kind of matrix. It's not really multicast, you're going to tell me, because it's not one-to-many, it's one-to-one, but that's the foundation of any over IP installation. All right, so now let's say that in your application it's not one-to-ones that you want. Actually, you are building a video wall, so that's one of the great benefits of this SDVoE technology. You can, on the controller up there, configure a custom video wall, taking those 4 receivers, upper left, right, lower right, and build a virtual video wall so that it becomes a destination, so that you can send the LG Blu-ray transmitter 4 to that custom wall. What happens? Well, again, the very same thing. The controller gave the instructions to both encoders and decoders of what they have to do. Here, they take one stream and they cut it in 4 different parts, right? So that the 4 receivers are subscribing to the 239.1140. So the IGMP reports from each of those receivers were sent to the courier. The querier confirmed that with an actual IGMP query that was acknowledged. So the IGMP join happened with every of your 4 encoders. The snooping table has been put together in the switch, and now you have your transmitter 4 packets going through each of those receivers, and of course those receivers know the logic from the controller. They know which bits they need to take, right? And of course this seems a little complex and difficult, but in fact it's not, because from a user experience standpoint, what you want to do maybe is not a drag and drop into an AV controller interface. You want to get through some programmation so that you have some touch panels for control that will have those big buttons so that the user can click or push a button so that everything we just seen happen this way. So if I take this last example again with the video wall, I want to send the transmitter number 4 to the custom wall. Pushing a button will trigger the drag and drop on the controller, and then boom, 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 you have your IGMP reports from each receiver that will instruct the querier. The querier sends queries that are acknowledged. You have the snooping table, and you are good to go. So now you understand that you need IGMP snooping and IGMP querier at the center of your network. So at the end of the day, what does matter? Well, the type of codec or the quality of your AV installation, as far as the switch is concerned, doesn't really matter, right? Because for a switch, after all, you don't have bad packets and good packets. We just move the packets. Latency is also out of question. Switches will never add any latency to your AV streams because a switch measures latency in microseconds, so 1,000 of milliseconds at the port level. So it doesn't matter. What is really important is the bandwidth, because of course you need to have the right bandwidth on every port and probably also between switches. And then you need to have IGMP snooping, IGMP querier and fast sleeve correctly set up. So now you know that from a IGMP standpoint, if you go with NETGEAR, if you go with a M4300 switch, for instance, you won't have to configure anything because luckily this IGMP snooping, querying, and fast sleeve is pre-configured for you. So out of the box, you just power on the switch, connect your video endpoints, your controller, and everything we just went through together is going to happen. But now that you have this original use case, let's consider this installation instead. This installation this time is not a single switch installation anymore. This time you have one switch on the left, which is maybe one floor in a typical enterprise or headquarter deployment. And then you have a core switch. Ethernet is a star system, so you always have the center of the network considered as the core, and then you connect your switches coming from the edge. In that installation, you have a whole lot of video endpoints of yours. You, for instance, here on such a 96X switch platform, you can have 40 different video SDVoE encoders and another 40 pack of video decoders. And that's okay, because in your business case, here, you're saying that, well, the multicast is meant to stay local. Most of these encoders and decoders will work locally on that very switch. But you only have maybe a pair of 10G or 40G links going back, heading back to the core, because you know that in this installation you will only have a few AV streams coming in and out of that floor, either coming from that floor up to the core or coming from the rest of the network to that floor. So that's why you spec your project this way. But what is going to happen? Well, I'm sorry to tell you that with the IGMP standard at the layer 2, without IP routing, all your streams coming from the 40 encoders on the bottom left will float to the querier. Because per the IGMP standard, all your multicast is sent to the courier because the courier got to know. So the courier needs to see them. So every switch will send their multicast streams to the courier. And if you count that with me right now, 40 10G streams, potentially it's going to be 400 gig, right? With two 40G links to your core, you are flooding, your whole network is down, nothing will work properly anymore. So that's a problem. So how do you handle that? Well, if you refer back to the RFCs, if you refer back to the IGMP snooping, courier, and fast-leave RFCs, there's no solution, okay? Layer 2 can't work. You got to go to the layer 3. You need to install layer 3 in your network. You need to have unicast wiring first between your subnets, and you need to configure multicast PIM wiring on top. Why do you want to do that? Because only with multicast PIM wiring, the network assumes that nobody is interested in any multicast stream, so the multicast will stay local on the bottom left switch, remember? And only if you have a subscriber coming from another place on the network, subscribing to a stream, then only then your multicast is under control and will be propagated through the network. Is that a problem? The answer is yes, because to configure multicast PIM wiring on this 1, 2, 3, 4 switch installation, it is already 60 pages of configuration, the NETGEAR network admin guides for the M4300 series or any other AV line series. This is very, very complex. And nobody really in this AV over IP ecosystem or industry should go that complex for AV over IP installation. So today I have good news for you, because we at NETGEAR understood that problem. We said, well, we got to fix it. So we did, and what we have done is that, well, we just rewrote the entire IGMP protocol, renaming it to IGMP+, achieving that very simple mission, which is, well, we want to consider that the multicast stays local on every switch. We will keep it under control, and we will only allow for multicast traveling between switches when there is a subscriber willing to subscribe to one stream. So we basically wanted to achieve the multicast PIM wiring objectives and efficiency, staying with the very simple IGMP courier, snooping under the IGMP+. So let me take you through that. In this very simple setup, if you have one core switch at the top, if you have two switches at the edge, if you have transmitter 1 and 2 connected to the first switch, transmitter 3 and 4 connecting to the second switch, I can assure you that with IGMP+ on a NETGEAR AV line switcher, transmitter 1 and 2 will stay local to the switch 1, transmitter 3 and 4 will stay local on the switch 2. Nothing, absolutely nothing will traverse and reach to the courier. In this example, I have the receiver number 4 on the bottom right, subscribing to the transmitter 1 stream by doing the IGMP report. Remember, the receiver number 4 sends an IGMP report to the courier. I want it. The courier at the core will confirm that with an IGMP query that will be acknowledged by the receiver 4. Then only at that time you open the gate so that the transmitter 1 stream travels to the center of the network wherever it got to go in order to reach the receiver 4. So you keep your multicast under control. So that is called NETGEAR IGMP+. This is available across the entire AV line switchers, 4250, 4300s, 4500s, for your efficiency. Of course, we didn't stop there, so that you know, if you have several other VLANs on your switches, because you not only have SDVoE for video, but you might have some QCs for control, some Dante for audio, under distinct VLANs, the auto trunk works in concert with IGMP+, so that you just focus on your access ports and you let the switches organize themselves, placing the uplinks in trunk mode. We call that auto trunk. And finally, if you want to aggregate more than one link between switches, remember on this headquarter installation, you got a switch bottom left with 2 40G links going to the core. AutoLag will detect those additional links and create the link aggregation group for you, so that you have more time to focus on what's important for you, which is your AV install. So IGMP plus AutoTrunk and AutoLag is the solution for your multi-switch installation. Let me take you through this example over there. Here, if you count, we have 32 encoders and 32 receivers on every switch. We expect that network to be line rate, so 8 40 gig links going to the core really allows for the full capacity with all encoders traveling to the network. That's a line rate network. But again, with IGMP+, as long as you make sure that your IGMP querier will be at your core, because you should restrict the number of hops, which you should make sure that the querier is strategically placed at the core of your network. In that case, even if you're not line rate, even if you reduce the number of 40G links, because you know that your multicast will stay local, you will not flood anything to the network until you have some subscriptions going on. All right. Well, that's my conclusion. Thank you for attending today. If you go to the netgear.com/ProAV, you'll see all the AV line switches we do for SDVoE installations. We are very proud to tell you that the 4300s and the larger core 4500s are all ready to go. And in addition to the IGMP+, if I have to convince you some more in order to go with NETGEAR AV line switches for your SDVoE installations, in addition to the hardware, in addition to the software with IGMP+, the switches come with a high quality support provided by a worldwide team of AV/IT SEs around the world, helping you at any phase of any of your projects, small or big projects. It's called the ProAV Design Team. It's only one email to reach out to us anytime, proavdesign@netgear.com, proavdesign@netgear.com. Any question from the design stage to the installation to the troubleshooting, because sometimes you have things to troubleshoot, this team will offer you the service you need with less than 2 hours of ETA. Well, it was a great pleasure again from the SDVoE booth at InfoComm 2022. Thank you for your attention today.